Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are happy with the content in this video, please press like, share and subscribe. Press the bell icon to get the notifications. If you are first time viewing this video, I will suggest you to go through my introduction video first to understand the structure of this course content. Today we are at basics of matrices. This is the basics class of matrices. Okay, so in this class we will understand first that the what matrices are, then we will go for its representation. After that we will understand the application of matrices, and at last we will put our road map that how we will proceed in this matrices chapter in further classes. Okay, so that is the intent of today's class. Now let's get started with the definition of the matrices. Okay, so you can see here what I had done. I had used three terms over here: dimensions, objects, arrays. Okay, these are the three terms: dimensions, objects and array. Now what we will do, we will connect these three terms. Okay, we will connect these three terms and understand how we get the matrix. Okay, we will connect these three terms and we will understand that how we will get a matrix, right? Okay, now let's get started. So let's understand this dimensions first. Okay, in dimensions we are having one dimension, we are having two dimensions. Okay, one dimension, this is a line, this line is a one dimension. Okay, two dimension, let us take this rectangle. Okay, let us take this rectangle. This rectangle is a two-dimensional figure. Why it is a two-dimensional figure? Because we need a two-axis plane. Okay, we need a two-axis plane to define this geometry. For 1D, one axis is sufficient. Are you getting it? Okay, so now let's see, concentrate more on 2D. In 2D we have this height and we have this breadth. Okay, we can tell length and breadth also, not an issue. So this is how a figure is there for 2D. For 1D we will only have length. Okay, for 2D we need a two-axis plane to define this geometry. Are you getting it? Okay, now let's move on to objects. What objects are? Objects are some things, like this is also can be an object. This is a line, line is an object. This is a quadrilateral or a rectangle, it's also an object. When we go for objects, it will be a number of objects. Here a line is a continuous line, but once I go for an object, I will draw this line. Just I will make some parts. Okay, let's give it more gap for easy visualization. Right. So, number of lines, number of objects. Right? It can be anything, toys, it can be dolls, number of things. Now, if we will take this rectangle. Are you getting it? Earlier it was a continuous rectangle. Now we had made a discrete number of objects. Okay. So these are number of lines. These are number of rectangles clustered in a group. That's it. That is the objects. Now, let's go to another term, array. This array is an elegant fashion organized objects. Okay, or we can tell objects organized in an elegant fashion. When an object is organized in an elegant fashion, then it is known as array. I can take the same example over here of this 4 rectangles. I told it is an organized in an elegant fashion. How can we now measure this elegancy? Measure of the elegancy is, this is number of rows and this is number of columns. Once we do the product of number of rows to the number of columns, then we will get number of objects in it. So like that we can tell it's an elegant organized. Are you getting it? Here number of rows are 2, number of columns are 2. 2 into 2, it's 4. So it's giving the number of objects. So that's why this will come in an array. If suppose I will add another rectangle over here, it will be the group of objects, but it's not an array. Why it is not an array? Because it's not in an elegant fashion such that the number of rows into number of columns will give you the number of objects in this. Are you getting it? So what my array is? My array is a highly organized or an elegant fashion organized objects. Are you getting it? These objects can be anything. It may be line, it may be rectangle, it may be toys, it may be some trees. Okay, so that is what my array is. Now let's come to the matrices. In matrices, array, I told that it can be an any object, but matrix is having numbers as its objects. Objects can't be trees or something like that. So matrix is used for numerical operations. Okay, so this is what is the matrix is. Okay, so a matrix is an array with objects as numbers. Okay, what is a matrix? Matrix is an array with objects as a number. Okay, now let's backtrace this chart now. Okay, let's backtrace this chart. What is the matrix? Matrix is an array where objects are numbers. So objects are numbers. Matrix is an array where objects are numbers. What is array? Array has objects organized in elegant fashion such as m cross n will give the number of objects. This is an array. Number of rows 2, number of columns 3, 2 into 3 it's 6. So it's organized in an elegant fashion such that m cross n will give the number of objects. Okay, what are objects? Objects are some dimensional figures. Objects are some dimensional figures. So objects can be a 1D, a 2D or a 3D object. If we take a toy or doll, something, whichever we are seeing in our surroundings, everything is a 3D object. Okay, so those are all our 3D. Now, why I stressed on the term 2D is it is used to show the size of the array. We can see while quoting m into n, we had used two alphabets over here. One is m and one is n. M is one dimension, n is other dimension. So it is a two-dimension thing. Are you getting it? So it is a two-dimension thing. Like this, here m is equal to 2 because it has 2 rows. Here n is equal to 3 because it has 3 columns. Right? 2 dimensions. It's a two-dimensional array. Okay? So it's a two-dimensional array. Okay? Now you understood what the matrix is? Matrix is an array where these objects are numbers. How matrix will look like? We will see in our next section. Let's proceed to our next section. Now, we are at representation of the matrix. Representation of a matrix. So, let's first reiterate that what the definition of matrix is. Matrix is the array of numbers. Okay, it's an array of numbers. So, I have written a matrix over here. First, it is 1, 2, 3, 3, 4, 5, 5, 6, 7, 7, 8, 9. So, this is a matrix. It's group of numbers written in a bracket, bounded by a bracket. Group of numbers bounded by a bracket. And it is arranged in an elegant fashion where the number of rows are 4, number of columns are 3. Okay, so let's see here. This is our row number 1, number 2, number 3. This is number 4. Okay, this is our row number 1, row number 2, row number 3 and row number 4. If you look into columns, this is our column number 1, this is our column number 2 and this is our column number 3. Okay, now by representing it with 1, 2 and 3 here also, it will create a confusion. So what we do, we will put a prefix of R for rows like R1, R2, R3 and this is R4, and prefix of C for columns C1, C2, C3 like that. Okay, so these columns are C1, C2 and C3, rows are R1, R2 and R3. 4 rows, 3 columns matrices. Number of elements over here are 12 and 4 into 3 is 12, right? Now this entire matrix represented by a letter A. It can be any letter, it can be B, it can be C. Then we will call it as a matrix A, matrix B, matrix C. If suppose number of the matrices are there, then we will call it as matrix A, matrix B, matrix C, like that. Understood? Now M into N. This M into N is the size of matrix. M rows, N columns. M rows and N columns. Understood? So A M cross N will give the complete representation of a matrix. A with the size M cross N, and number of objects will be M into N objects. Okay, in this, are you getting it? Okay, now let's move into the objects level, that is level of 1, 2, 3, these objects in the matrix. We can see here, these are all our numbers written in the bracket. It's bounded by a bracket. Now if I will call a number 2, then we can tell that its position is here. So what is the position of 2 in this? Position of 2 in this is first row and second column. Position of 2 is first row and second column. So far so good. If I will ask, what is the position of 3? We see that there are 2 positions of 3. So it's very difficult to pick the element in a matrix by its number value or its numerical value. So what we do, we will provide an representation to each element that we will show by A, I, J. How we will show? We will show by A, I, J. It may be A, J, K also. It may be A, L, M also. Okay. So just I have taken a generic alphabets, which is I and J. A, I, J, where I will show the row number and J will show the column number. Suppose I will talk about 6. So what is the row number of 6? It's 3 and column number is 2. So it is A32. So when I will tell it is A32, then it means it is 6 for this matrix. Like that. Now specifically if I have to talk about which 3, then if suppose it's second row and first column C, then I will tell A21. A21 is second row, first column 3. So I am now specific about which element it is. If I will tell 3, you will be getting confused whether it is this 3, this 3. If I will tell 5, then you will get confused whether it is this 5 or this 5. Are you getting it? A matrix can have a repetition of number value. But to be specific on that, we are representing each and every elements by Aij. So it's now a standard practice to represent each and every object or each and every number in a matrix to be represented by this. Okay. Now let's move further. Other than representing an element by Aij, what other benefits we will get? What other benefits we will get if I will represent it with Aij? So here, if I want to perform an operation, okay, if I want to perform an operations, so let me give an example of the operation in our local language. Suppose we are having one municipal corporation. There will be number of wards. Okay, in a municipal corporation there are a number of wards. In these wards, after the election, someone is the representative. Then that representative in his ward, like ward number, suppose his ward number is number 8. Then in his ward he will distribute the dustbin. Okay, he will distribute some utensil. So what he is doing? He is performing one operation in its wards, right? Another ward, they will give some first aid kit. Okay, their representative are distributing some first aid kits. So each and every ward is having their own operations. Like that. This matrix, these are the wards. If I want to perform any operations to these wards, like I want to multiply 2 in my entire first row, and I want and rest all terms as is, and I want a sum. So are you getting it? I want to multiply 2 with entire first row, and I want to get the sum of entire these numbers. Then how I will represent it is, I will represent it with by sigma. I have to multiply 2 in the first row, then it will be 2. First row is represented by A1. It will be J, because J can vary, A11, A12, A13. So this will cover the entire first row. So J is from 1 to 3. So entire first row is covered. Now I will write rest all. So it will be plus sigma I is equal to 2 to 4, sigma j is equal to 1 to 3 a I j. Okay, so whatever I told the problem earlier, that a 2 is multiplied with all the elements in first row, 2 is multiplied with all the elements in first row, and rest all numbers are summed as is represented by this. So this is the another use. So A11, A12, A13, rather than giving addresses, it is used to represent in the form of these series. the sigma represents sum of all the elements. Okay, so here you can see it is j is equal to 1 to 3, so it will be a11, a12, a13. It will cover all the 3 elements. Now from I is equal to 2, that means it is starting from second row. J is equal to 1, that is it is starting from first column, so it is starting from this point. This is the starting point of second term. Now j will run from 1 to 3, so it is 2 1, 2 2, 2 3. Now I will become 3 next term, so it will become 3 1, 3 2, 3 3, 4 1, 4 2, 4 3. Like that we had covered the elements from row 2 to row 4. Are you getting it? Not only this, if some square matrix is there, we will discuss in the types of the matrices that what are these square matrices are. So in the square matrix is there, then to apply operation on diagonal elements like that, or some constrained parameters, like if suppose second row and all elements certain constraint parameters, then this representation is very useful. Okay, so not only give the address of each and every number in a matrix, it is also used to provide this representation. Okay, are you getting it? So this completes the representation of an matrix and the address of each and every element. Now let's move on to the operations and applications. So let's complete the applications first. Okay, then we will discuss that how we will operate this class further. So let's move on to the application of this matrices in the next section. Okay. Next, move on to the application of this matrices. So far, we had learned that matrix is a group. So in mathematics, wherever you see a group solving, like solving the linear equations, one variable if it is there, only one equation is sufficient. So matrix formulation is really not much useful in that case. But once the variable increases, like 2 variable, 3 variable, 4 variable, 5 variable, so a 4 variable equation needs 4 equations to solve it. A 3 variable equation needs 3 equations to solve it. Like that, when the number increases, its group increases, then matrix becomes very important in those cases. We will group and we will perform the operations in that, like multiplying with 2, multiplying with 3 for each and every rows and columns, and we will come up with the solution. That technique is used to solve the different problems. Okay, so matrix are used in solving linear equations. It is used for some transformation problems. So if we move on to our next classes, we will see how the transformation from one point to the another point, if you want to shift, if the line is going to shift by some angle, rotate with an angle, then what will be the coordinates, all those things. For those transformation, matrices are very important. Matrices are important to solve the differential equations. Okay, some sort of differential equations you will be learning, but if we go for higher approach, like of our numerical methods and all, which is in our higher classes, matrices are very important. This is just, I had written down 3, but there is really a very huge application of the matrices wherever we can apply our operations in a number of objects or in a numbers in a group. Okay, so this is what is the application of the matrices. Okay, solving the linear equations we will discuss in detail in one of our detailed explanation class. Transformation we will have a look over here, and differential equation numerical methods are really, it's a high standard work which we are not going to discuss in our these classes. Okay, chalo, now in next section we will move to see how we will operate this entire matrices class to make you understand the concept, to make you competitive also. Okay, let's move on. Let's now discuss that how we will move forward in this matrix unit. Okay, in this matrix unit of our classes, how we will move forward. In next class there will be a detailed explanation classes. In detailed explanation classes we will discuss these topics. First, operations of matrices. Operations means two matrices added together, matrix multiplied. Okay, there are some matrices within it, some operations within it. Okay, matrix is there and some operations are within it. Such type of discussion we will have in operations of matrices classes. After that we will discuss determinants. Determinants is a very important, and we will discuss that in this detailed explanation class. After that we will discuss types of matrices. This is very important to know what are the different types. For a simple thing I will tell now, like if suppose number of rows and number of columns are equal, then it is called as a square matrix. So such type of very small bits of definitions for each and every matrices we have to identify by seeing a matrix itself, that what type of matrix it is. Okay, by operations and determinants we will be comfortable with the matrices operations and we will know about what determinants are. Then it will be easy for us to understand what are the different type of matrices. Okay, by performing the specific operations, if there is a specific result, by performing some operations, if there is a specific results, then those matrices are classified in some other group. We will see those all things in this types of the matrices class. And at last I told in application section itself that one application is linear equation. We will go through this in this detailed explanation class. Are you getting it? So we had planned for these 4 detailed explanation classes. In these 4 detailed explanation classes we will learn about operation of the matrices, we will learn about determinants, we will learn about type of matrices, and we will learn about the linear equations. Okay, after this detailed explanation classes we will have a working sessions, a workshop session. Okay, in those workshop sessions first we will complete the board level questions. It may be a 3 workshop sessions or 4 workshop sessions. We will complete the board level questions. After that we will move forward to go to the higher level of problems. Okay, this completes the basics class on the matrices. If you are happy with the content, please press like, share and subscribe. For further classes, stay connected. Thank you.